Got a couple practice problems here to get you warmed up for the exercises in the 3.2, first two sets of exercises. In these exercises, like the problems I'm going to do here, we're going to let P and Q be true. Okay, we don't know what they mean. We're just assigning that for the purposes of practicing the operators in arithmetic here. We're going to let R and S be false. So, to calculate, I have to know how my operators work and plug in the appropriate sort of arbitrary stipulations here. Well, entirely arbitrary stipulations. P and Q are both true, so I have true or true. If and only if. R we're given as false. Need to calculate in parentheses first. This is one of the things mentioned on page 40. Calculate in parentheses first, and always also negation applies to the smallest thing that's allowed by parentheses. The negation right here always applies to what is to its right. Alright, true or true. Or is true when at least one of the two things are true, including the case where they're both true. So in the parentheses I have true, and that gives me true if and only if false, which is by definition false. If and only if, you just got to get used to it. You got to memorize these things. They're the basic parts of what we're doing, basic definitions. If and only if is true when both expressions are the same truth value, and it's false when they are opposite. Alright, problem number 2. We have false, if and only if, false. R and S are both given as false, and not false. Could go either way, but let's go in the parentheses first here. We could just negate the true, and that wouldn't affect anything. False, if and only if. False is by definition true. Both expressions are the same, if and only if. Alright, then I could write this in two separate steps. I'll go ahead and write it in separate steps here, just one thing at a time. You might have gone ahead right to this step where we get true and true. And that is, by definition, true. Negation of a false claim is true. Negation true is false, incidentally, and is true when both expressions are true, and only in that case this expression is true. Alright, so going on to the third one, I begin by substituting in the truth values for our different claims. R and S are both false. P is true. Calculate in parentheses. Let's do that first. If false, then false. It's true. Horseshoe's false only when we have T horseshoe F. Negation. I'm going to go ahead and do it step by step here. We might skip one step again, but I'll end up with negation false. It's T horseshoe T. Then I'm going to go ahead and slowly calculate what's in the parentheses. T horseshoe T, which is true. So I have true or not true. It's true or false, which is by definition true. And that would be the final truth value of the expression. Notice that if you think about what you're doing, once I got to this point right here, this step, true or, it's not the case that in parentheses if true then true. I really didn't need to calculate the truth value of the expression to the right because I had an or claim, one part of it is true, that automatically makes the entire claim true. So as you understand the things, you'll be able to see some shortcuts along those lines. But of course, be careful and make sure your shortcut is not a mistaken one.